All right, this is the limit comparison test. We're still working with series, so infinitely long lists of numbers that are getting added together. And we're still asking the question of how can we tell if this is going to be some finite number or be infinitely big. Uh, this limit comparison test is going to give us another tool for determining this by comparing a certain series to another series. All right. So before I jump into that, I want to talk about these three series we have here. So the green one is adding together the numbers that look like 1 over n squared. So we're starting with n equals 2. That's so that this blue one works out well. That's fine. So with this green series, we're adding together 1/4, 1/9, 1/16, 1/25, etc. So we're taking this infinite list of numbers and adding them together. This blue one is going to be differing from the green one in that the denominator is going to be one less. So 1/3, 1/8, 1/15, 1/24. Each of these denominators is one less than the denominator of the green. With the reds, the denominator is one more. Okay, so I want to think about how these series work. First off, this green one is sort of the simplest. And in fact, this green one is very similar to one we've seen before. Because this series is always positive and always decreasing, one thing that we can do is use the integral test. Or more specifically, the p-series test says that because this 2 is bigger than 1, this thing is going to converge. Okay. So this is going to converge by the integral test. And so you might be thinking of like, oh, well, we could just take the integral of each of these. And yes, that is a thing that we can do. But these are sort of the simpler examples to illustrate this limit comparison test. The limit comparison test is going to be able to work in situations that aren't necessarily always positive and always decreasing. So this is more general in this particular case. If all I asked you was whether or not this red series converged or not, then yes, just taking the integral would be a valid way of doing this. Right. So the way I want to think about this is I want to plot what these numbers look like. I want to get some graphical picture of what this series is doing. So I want to start off by plotting these just the green individual values. So thinking of this as a sequence. So I'm going to be plotting 1/4, 1/9, 1/16, 1/25. Okay, so we have all these numbers. I want to point out that we can determine, if this red series converges or not by just using the comparison test. If we plotted all of these red numbers, they would all be a little bit less than these green numbers. So 1/5, 1/10, 1/17, 1/22. And I want to point out that if we're adding together all of these red numbers, because each of these red numbers is less than its corresponding green number, the answer that we get has to be less than the answer we get from this green series. So this red series is going to converge by just the comparison test that we saw in the last set of videos. Okay, but this video is about a different test, the limit comparison test. These are two separate things. And what we want to know is whether or not this blue series is going to converge. So let's draw what these blue numbers look like. For each of the ends, the blue number is going to be a little bit bigger than either the green or the red. And we're going to get something that looks something like this. So we can't directly use the logic that, well, blue was, so with red was always smaller than blue. Sorry, excuse me. With red, we could say red is always smaller than green. And because green is finite, that means that red is finite. We can't use that logic with blue because blue is always bigger than green. However, all these series look really similar. In fact, like, especially as we start approaching infinity, these are going to get clustered really close together. So we really want to say that this blue series feels a lot like the green series. And what the limit comparison test does is it lets us make a statement like that. Make a statement that says, hey, a particular series looks similar to, or feels like it behaves in a similar way to a series I already understand. Okay. So here's the statement of the limit comparison test. If we have two sequences, AN and BN, and that are always positive, and if in the limit, their limit is just some constant number, then the convergence and divergence of these two series are linked. In other words, if we have our AN is going to be, which one is easier? Our AN is going to be 1 over n squared minus 1. Our BN is 1 over n squared. We're going to compute this thing. And as long as that is just some constant number that's bigger than 0, then the fact that the series sum of BN converges means that the series sum of AN also converges. So all we have to do is calculate this thing, the limits as n goes to infinity of 1 over n squared minus 1 over 1 over n squared. This is just multiplying through by this is just multiplying through by n squared, which ends up looking like n squared. And once it's written like this, you may have a hunch that this thing limits towards 1. We could do a little bit more algebra to make that even more clear by dividing through by n squared, and we get 1 over 1 minus 1 over n squared. So as n goes to infinity, this term goes to 0, and this thing ends up equaling 1. Okay, so because the answer that we got here is some constant, some c that's bigger than 0, what this is telling us is AN and BN are similar enough that their series, the sum of these things, either both converges or both diverges. Whatever the behavior of BN is, that's the same behavior of AN. So this limit comparison test tells us that this blue series converges. So this converges by the limit comparison test. This exact same logic would also show that this red series converges. So this red series we could do either by the integral test, by the regular comparison test because it's always smaller than green, or by the limit comparison test. This blue sequence, this blue series we could not find by the regular comparison test. However, the limit comparison test does work.